All right. So hey, hopefully this thing right here reminds you, brings back great memories. If it brings back traumatic memories, then hey, it brought back memories. A little trip down memory lane back in the day when we used to, you know, meet with other people besides our immediate family members. It could happen. It could happen again. But plenty of people don't really want that. Now, with this is a unit circle, and I had to find and search around because a lot of unit circles will actually leave off this 360 degrees and the 2 pi right here. Um, and yeah, so but it's really important. We want to go all the way around. And again, too, mention this. I'll mention this lots of times. The unit circle goes round and round all through the town, just like the wheels on the bus. It goes round and round, which means that we could go 0, 180, 360, 540, 720, and just 900, 1080, and keep going on and on and on, all the way around, round, 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 round. Okay. And you could do it, until the cows come home. Um, you know, Theoretically, you could go on until forever. But, it's just one of those things that we like to do. You could also go backwards too, and so we can have negative ones. Right now, what we want to do is just concentrate on getting used to using this again. We're going to be taking a look at some different things going on. You can see that we have these coordinates. The inside, we have the degree measurements going 0, 30, 45, 60, 90, 120, 135, and so on all the way around. You can read. Again, if we were in person, I'd have you memorize that. I'd have you memorize what these ones are, the radian measures. A few things to note that I like to do, anyways, is I like to think of this as a series of rectangles inside of the circle. So, yeah, you know what? Let's do that. Let's do that. So I'm gonna do this right here. Okay, and then let's put this. So, good old buddy of paint. Control V. All right, and so. Nope, that's not what I wanted. Home. Home, that's the one. Okay. So I'm going to put in a rectangle. And if we come right here, and you can see, well, it's not a perfectly drawn circle. So, but you can see you got that rectangle going on. It connects all those. All of these corners are pi over 6, pi over 6, pi over 6, over 6. Everyone's over 6. And the coordinates, the x and the y, the absolute values of each are the same. Radical 3 over 2, 1/2. Now, then, as long as you understand how the coordinate system works, which is actually lacking from here, it's one thing that I think that they should include, is we should have something that does this and say, hey, this right here, this is the x-axis, like so. We have the x-axis, and then we also have got the y-axis going on up here. We got the y-axis. Okay, so you got the x-axis and the y-axis. And so if you understand the coordinate system and which coordinates, which quadrants are positive and negative, how the x values go, then you'll be fine, totally fine. All right, so let's get it, and then you could do, let's do another color set for the rectangle. Let's go with green. Okay, a little bit of school spirit going on here. I got spirit, yes I do. I got spirit. How about you? There we go. And so now we have the our this one. All of these on the square are all over 4. And the x and y are exactly the same, the radical 2 over 2. And one more again for, how about, oh, they just did that again. All right, let's click out. Home. And, oh, green. Yeah, Christmassy. So, and one last rectangle, and you can see right there that all those, the corners are over 3. And again, the coordinates match up, just negative, positive sort of deal. Few things you can look at too. I like to point out, but if we're working on just some things for you to memorize, I think is really good to find some way to memorize this, especially if you're going into calculus, because you need to have it not so much even that you can recreate it, that you just see it in when you close your eyes and it's just part of who you are. You want that to be so natural. Now, using the unit circle is what we're going to concentrate on now because you have the unit circle. All right, so using the unit circle, and there I am. Okay, that's what I want to do. All right, so a few things that we need to understand about the unit circle, buddy, is that, okay. So on the unit circle, we have a few things. Sine of our angle is y, the y coordinate. Okay. Cosine of the angle is the x coordinate. Tangent of our angle is the y over the x because it's sine over cosine. Secant is, well, no, not secant. I want to go with cosecant. So cosecant of our angle is 1 over y, or another way to call it the reciprocal of sine, or y. Okay. The secant is going to be a reciprocal of your x, and then the cotangent is going to be the reciprocal of tangent, or x over y. We're going to flip those over. So this is the way it works out. So using the unit circle. Now, so what we'd want to do then is, so I'm going to have you fill out a chart is what I'm going to have you do. And this chart is what we're going to use to, kind of just practice doing this stuff. It might feel a little drill and killy, but that's okay. Plenty of us survived that back in the day. So I think you'll be okay too. Heck, you made it this far. So let's say we take an angle like pi over 6. Okay, so what I'm going to do is I'm going to give you a table, and you're going to have pi over 6 is going to be a radian. Then I want the degree. Now, preferably, you just automatically know that this is 30 degrees. Now, if you don't, you can go to the conversion. You can look at our unit circle and see pi over 6 and 30 degrees. But you want to really get to that point where it's trained and you just know it. All right, and then we're going to go through and we're going to have the sine of our angle, cosine of our angle, tangent of our angle. And how do I write it? How did I write it? Let's see if I got it where I got it. Let's just look here. Using or something, maybe unit circle chart. Unit circle chart. That's the one. Nope, that's not that one. Okay, so that'd be good practice for you. Fill in the unit circle. I'll share that with you too. But I'm sure I got it saved someplace. Anyways, however it goes. So we got cotangent theta, secant of theta, and cosecant of theta. All right, so the sine of theta, again, this is the y value. So what you could do is you could look at the unit circle. You can fill that one out. So unit circle, the y value at pi over 6 is 1/2. And so it's just come back over here and we're like, hey, boom, 1/2. Nice. Cosecant is the reciprocal of that. The reciprocal of 1/2 is 2. So I put that. Sweet. All right. The cosine then is going to be radical 3 over 2. But if we just look at, again, I want you to just, if you see cosine pi over 6, I want you to think radical 3 over 2. But until then, you can see, hey, look, that's the x coordinate. The x coordinate is radical 3 over 2. So radical 3 over 2. Now, if we go and we flip that over on the secant one, that's going to be 2 over radical 3. And now probably somebody along the line told you that you shouldn't have radicals in the denominator, which makes a lot of sense if we're using slide rules. But probably a lot of you don't really even know what a slide rule is. And because of that, it doesn't really make a lot of difference. But if Skynet should ever become self-aware, then we can't trust our electronics anymore. Or if somebody decides that they want to change what 2 divided by radical 3 is, and you just do it without you even thinking about it, then you got to be ready to use that slide rule. So this becomes 2 radical 3 over 3. And you just multiply this by radical 3 over radical 3 to get there. Or you can move that to the top and take off the radical on the bottom. It's the same thing. All right, now the tangent of theta is going to be this over that. So we'd have, this would end up being, I'm just going to do this over here. So the tangent of pi over 6. So you have the y over the x. And again, so what we're going to do is we're going to multiply by the reciprocal of the denominator, because you know how to divide by fractions, since you deserve to be allowed to leave out elementary school. And so this comes out to be 1 over radical 3. And that's going to be, so that's the idea, multiplied by radical 3 over radical 3. You get radical 3 over 3. Okay? Now, these two things are equal to each other, which means they're equivalent. That means they're exactly the same thing. There's no difference between radical 3 over 3 and 1 over radical 3. They're exactly the same number. And you can check me by putting them into your calculator. But since these are the same, and cotangent's the reciprocal of tangent, what we can do is just do the reciprocal of that one, because it's a lot easier. So if we do the reciprocal, we get square root of 3, or root 3, or root 3, or rad 3, or radical 3, or however you say it. I don't really care. But that's the idea. And so we want to fill this out, going all the way around, hitting all the different ones. And so that's the idea. So you go through, there's 30 degrees. What's going to happen is if you go through, there are patterns that emerge. And these patterns are going to be very necessary to help us to be able to graph these things, to understand how the graphs work. And that's the goal, is we want to be able to graph these. And so we're going to get here. This is where we're going to start with this chart, to be able to have this chart, to be able to plot the points, to see where the graphs are. So that way we can think on our own and not have to rely on Mr. Desmos. So give that a shot and see how that goes. And let's see. Good. Yeah. Fun question. How about real. Let's get real. If we could go back to school, if we could be back in person, or you had the choice, you got to choose. You could be in person every day of the week. Okay. You could be in person 2 days out of the week. You can be in person 1 day out of the week, or you could just keep doing the virtual learning. Which would you prefer? Of those 4 options, which would you prefer? Because you still have to do school. So either you could keep, you could do, if this was your choice, okay, I have this is not going to affect anything whatsoever for a number of reasons. But first of all, nobody's going to listen to me. But I want to know, what would be your choice? Stay online. Back at school 1 day a week, at home the rest of the time. Back at school 2 days out of the week, home the other 3. Or at school 5 days a week. What would be your preference? So I'm interested to know. Everybody back in school 5 days a week. And you know what? I'm okay if some people, life is dangerous. The world is dangerous. I think we've forgotten that. So that's my thoughts on the matter. So my 5 days a week, everybody back in school. Heck, I can even bring my kids and we can all hang out together too. But that'd be what's yours? We'll talk to you later. Where'd it go?